Okay, so what we're doing in this problem is we are looking to see how we calculate percents if one thing depends on something else that happened. Okay, so there's a couple of events that depend on each other. So police often set up sobriety checkpoints, roadblocks where drivers are asked a few questions to allow officer to judge whether or not the person may be drinking. If the officer does not suspect a problem, drivers are released to go on their way. Otherwise, drivers are detained for a breathalyzer test that will determine whether or not they're arrested. Police officers think, let's see, where's my mouse? There we go. They make the right decision on stopping somebody 80% of the time. And at a time, the National Traffic Safety, after they're stopping people after 9 p.m., and they think about 12% of the people after 9 p.m. have been drinking. So what we have to do is we have to make something called a tree diagram. And so we have to think about what are the options that could happen. Well, the first thing that has to happen, what's controlled, is you're either drinking or you're not, or you're sober. Those are the two options. So what happens, you get to a stop and you've either been drinking when you're at that stop or you have not been drinking and you have the stop. And so you're one of these two things, an officer talks to you. And from that point, the officer either detains you or lets you go. So he either detains you or lets you go. Now, this one's a little trickier than some, but we need to look at this first highlighted thing. It says that officers are able to make the right decision 80% of the time. So if you've been drinking, right, the correct thing to do is detain you. So this number right here is 80%. These two numbers have to add up to 100%. So 80% of the time, if you've been drinking, he's going to detain you. And then that means 20% of the time he's going to let you go. All right. When you're sober, the correct thing to do is let you go. So the correct decision they do is 80% of the time they let you go. And then when they detain you, that's the wrong thing to do. That's 20% of the time. So now here we look at the first numbers. And right here, this is where the second thing comes into play. It says 12% of drivers have been drinking usually at this time at 8 p.m. So we don't know if that's for sure, but we're going to use those numbers based on what the national report says. And so 12% of drinking, and so that leaves 88% are sober drivers. So what happens is you kind of have to follow this tree diagram out. So there's 4 options that could happen. I could be drinking and get detained, drinking and let go, sober, detained, sober, let go. And if you notice kind of what I said, I tried to say it specifically, but maybe not enough. Drinking and detained. So to find this one, I'm going to do 0.12 times 0.80. And so the percent of time that this happens is 0.096. So about 9.6% of the time, someone has been drinking and they are detained. Okay, and so now to do this next one, again, drinking and they let them go. So 12% times 0.20. And that should be 0.024. Yep. So 2.4% of the time, that's what's going to happen with all the stops. Now there's 2 options for sober. You could be sober and detained. So it's 0.88 times 0.20. Which is 17% of the time, 0.176. And then this one, sober and they let you go, that's going to be the biggest one because those are both the highest percents. 0.88 times 0.8, which is 0.704. So out of all the options that happen, these are the 4 different percents that they happen. And if you know you've done this right, if you add those numbers up, they add up to 100%. Okay, so now that we have percents of what could happen, we have to answer our questions. Question A, it says you're stopped at a checkpoint, and of course you have not been drinking, so that means you're sober. What's the probability that you're detained? So what you do is you follow this track, okay? Let's do a different color to highlight. I am sober, I am detained, and so it's this percent right here, 0.176, okay? So I'm gonna get rid of that highlighting so that I don't have it for the next one. So 0.176. You could also write it as 17.6% of the time. All right, question B. What is the probability that any given driver is detained? Okay, well, let's highlight this. There's two ways to be detained. You can be detained here, which means it's this number, and you could be detained here, which means it's this number. So you could be drinking and be detained, or you could be sober and be detained. So there's two different options, and so because it's an or problem, you're going to add those two numbers. I'm going to get rid of those highlighting so I don't have them for the next problem. So detained, drinking and detained was 0.096, or, which means add, sober and detained, 0.176. So I need to add those up. And so that is 0.272, or 27.2%. Okay? I think you're supposed to have more problems, so give me a second to find out what happened with them. Okay, I found the other two problems. So what's the probability? So we'll do C. What's the probability that a driver who is detained has actually been drinking? So here's the thing that's going on. It's saying, what's the probability that a driver is detained? That's kind of a conditional statement. So out of all of the ones that have been detained, so this is asking for the probability of actually be drinking if you've been detained. So this is a conditional probability. And so you have to read them very carefully to understand that that's what's going on. Okay? And so this is a conditional probability on these can get a little tricky. You have to look at all the ways that you can be detained. And right here, let's see, I can be detained right here. And I can be detained right here. There's two ways to be detained. So those are the two numbers that become my denominator because there's two ways to be detained. So 0.096 plus 0.176, because those are the two ways you've been detained. Now out of those, which ones were actually drinking? Those are the ones up here that were actually drinking, that were detained. Okay, so that's the 0.096. This is going to be the hardest type of problem because people are just going to go straight to the 0.096, but you have to remember that it's out of those that have been detained. So it's a conditional probability. It's asking you to look just at those. So it's 0.096 out of 0.272. And so now I divide that and I get 0.353. So 35.3% of the time, someone that's been detained has actually been drinking. Okay. All right, I'm going to get rid of those two arrows so that we can look at problem D. All right, so for problem D, what's the probability that a driver was released had actually been drinking? Okay, so this is telling you to look at the released ones. So the condition here is drinking. They've been drinking, but they're actually released. Oops, let's spell released right. So what we have to do is we have to look at those that have been released. And so here I can go ahead and highlight, because this is our last problem. So released is the same as they let them go. So there's two ways to be let go of. I could be let go after been drinking, after I have been drinking, or I could be let go after I have not been drinking. And out of those, the ones that were actually drinking was here. Okay, so again, this is a conditional probability, so you have to be careful with these. 0.024 plus 0.704. So my denominator is 0.728. And so the probability of somebody that's been drinking that's been released has actually been drinking is 0.033. So a very small percent of the time, but it does happen. Okay, one trick that I can tell you is that if they're making you do a tree diagram, there's probably going to be questions like C and D that are conditional, because otherwise you can find the answers without the tree diagram, but the tree diagram really helps visualize and for you to see the answers for conditional probabilities when you're working with probabilities of one event affects how the other event happens.